Good morning. This is Gregg Lippa. We are moments away from starting our webinar today. I'd like to thank you all for coming. My name is Gregg Lippa. You can see on the slide how to reach me and how to reach Themis. Our webinar today is Modernizing the Mainframe with Java. Obviously, the mainframe's been a bastion of COBOL and some other languages for many years, many decades, and Java is the new kid on the block, less than 20 years old, and more and more we can embrace Java in the mainframe environment. And this webinar, I will try to keep to 45 minutes. I will probably fail. I've got 70 slides, which is a lot. I'd like to ask if you have questions that you use my email address. You can see on the slide. And I will get back to you with answers to your questions. If you feel like you have a really quick question to clarify something, you can use the chat window in GoToWebinar to ask your question that way, and I'll try to keep track of those. All right, so let's get started and see what this webinar is going to be about. We want to talk about why to use Java, what are the advantages of using Java on the mainframe, where can it be used, which in mainframe environments can you use it in, how is it supported in various environments, including DB2, CICS, batch, and others. What if you want to access ZOS-based files like VSAM files? Can you do that? How do you do that? And what if you want to interact with COBOL or even PL1 modules? Are there ways to do that? One of our big topics today is the WebSphere server, which has been around since the beginning, 1998, when Java Enterprise Edition came out. IBM was there with WebSphere server, but it's been enhanced recently to support extended deployment, something called Compute Grid, and we'll talk about that at some length. We'll also get in a little bit to how message queues can be used, fairly commonly used in the Java environment, and a quick look at XML primarily to talk about how web services fit into the Java and mainframe picture as well. So think about the legacy systems that you're working on and maintaining. There's a life cycle. It goes beyond development and implementing the initial system. It's followed by maintenance, modernization, and replacement. So we have to keep it up and running. We may want to modernize it and bring it into new interfaces or new coding structures. And ultimately, we may replace it with a whole new system. The modernization and replacement phases are where Java can come in and be helpful. You know, we can maintain it for years or decades, and finally it just is too old and clunky to move forward. You know, the user interfaces are out of date. Even the operating environments may begin to get out of date. So one simple approach that really doesn't involve modernization is often referred to as screen scraping. It's been around long before Java. The idea of just providing a new interface used to be in Windows, now some kind of a web-based interface, but keep the code behind the same. So have still a CICS transaction running in the background, for instance. Now there are tools to help with this. It's less risky than rewriting a whole system, but it's not true modernization. And these kinds of solutions get increasingly difficult to deal with over time. So the replacement phase, this has the possibility of introducing the most risk. When you replace a whole system that works with a system that hopefully works, and hopefully works as well or better, things can happen. So it's not something that we're going to take lightly, and it may not be particularly cost effective, but there still may be reasons and drivers to move to a modernization, and Java may be the best way to do that. And these can be online systems. They can also be batch systems. A lot of our focus is going to be on how Java fits into that batch environment. Why do we want to replace our systems? Well, one factor that many organizations are up against is the availability of skills. COBOL developers, frankly, we're getting old. We've been doing this for decades, and a lot of that talent is nearing retirement age or has already retired. While Java is a very common skill that's taught in our universities, and we have a much larger pool of potential developers with Java background. Number two, integrating with other systems. If we're trying to connect with internet-based systems or other systems our suppliers and vendors and business partners use, Java can be a good way to do that. Performance, Java's been improving. We'll talk very little about Java performance, but it is something that IBM and many others have focused on. And finally, portability, the watchword for Java, write once, run anywhere. This ability to run your application on ZOS or to run it on some other server environment like Unix or Linux. Benefits of Java, being an object-oriented programming language, comes with many benefits which we're not going to detail here. You can find those anywhere. Take my word for it. Portability, again, Java does not compile to machine code. It piles to an intermediate element called bytecode, and bytecode can be interpreted on any operating system, where machine code is specific to the operating system it's designed to. It's a complete language, supports all kinds of programming, even some assembler type of programming approaches, and support for multi-threading. Java's been used for website development for many years. It's one of the primary ways that the Java Enterprise Edition is used, and there is widespread support within IBM and outside of it for developing web-based applications. There are also a whole variety of open source and other tools and add-ons available. Some other benefits of Java, we have the functionality, things that may be available in Java that may be more difficult to do in legacy systems. We have XML processing capabilities. We'll talk a little bit more about XML a little bit later on, but support for web services is frequently one of the many drivers for using XML. We have, if we have WebSphere Java Enterprise Edition programs already running, we have a lot of program logic and Java elements that we may be able to reuse in a batch type environment. Number four, server consolidation, having our WebSphere running on ZOS seems to be popular today. And number five, zip processors, Z integrated something or other processors that basically make it more cost effective to run programs written in Java and various other things that are supported. Zip processors can result in cost savings, as many of you already know. So let's take a look at the batch Java environment. We know what a batch application is. No terminal, no browser, probably a large workload, probably runs at night, probably processes thousands or millions of records, and gives you efficiency and high levels of throughput, and the ability to use workload management techniques like WLM. Java Batch can be used for a variety of scenarios, including large volumes of data, whether that's flat files, VSAM, DB2, or other types of files. Also, communication with other environments using messaging, what we now call IBM MQ. Used to be MQ series, WebSphere MQ, to integrate with other environments. We have the ability to work with reporting and print large amounts of reports. We also have possibility that our vendors may supply applications that are delivering Java Batch capabilities. What can you do with the Java Batch application? Well, you can work with a variety of file structures, including DB2. You can call DB2 any number of ways, including stored procedure calls. You can also use MVS datasets, including VSAM datasets, and Unix files, which are probably not that typical, but also and even more easily available. You can use JCA and interact with CICS or IMS applications. You can use the network protocols, including TCP/IP and HTTP. CPU-intensive calculations particularly can benefit from the zip processor when they're written in Java. And you can integrate with other languages in a few fairly low-level ways that we will not talk a whole lot about, but they are available. Many APIs are available on ZOS to support Java. We've listed 10. We've highlighted 5 of them. Access to MVS datasets is a big one. And then number 5, being able to take copybooks targeting COBOL programs and convert them to be usable in Java. We'll talk more about that. Invoking efficient sorts, number 8, integrating with RACF, 9, logging, capability of submitting jobs, a whole set of capabilities. IBM is strongly supporting the ability to have Java take on more and more of the workload in a modernized environment. In terms of data access, obviously DB2 contains most of our data these days, the enterprise data, and JDBC, Java Database Connectivity, allows you to get at that data, not just through stored procedures, but directly as well with SQL. Additionally, access to sequential files, PDS, VSAM, are all available in ways that we will talk more about and mention right below using the JZOS Toolkit Library, basically Java on ZOS. As some of you know, Java is able to work with files, which it uses a framework called streams, but they don't work with the standard MVS type files like VSAM files or flat files. So JZOS supports making that kind of file access, and we'll talk a little bit more about that, obviously without getting into all the details of it. What JZOS is basically a thin wrapper around some C++ functions that have been available to access these MVS datasets for many years. So they give Java the capability of accessing, as you see in the bottom, sequential files, PDS, and most kinds of VSAM files. Obviously not linear data sets, but the other 3 kinds of VSAM files that are listed there. Now again, COBOL copybooks are so central to our mainframe systems that being able to reuse those in a Java environment can be a very useful thing. And the types of data that are supported in COBOL and through those copybooks need to be converted to be supported by Java. And there is a utility program, and I'll talk a little bit more about that in a minute, that allows a complete set of field converter types to be used to support these COBOL types in a Java environment. Here's a little more detail about that. There is an automated process that runs at development time and allows you to use the AData output from a COBOL compile. You check off one of the compile flags and take your AData output as input to the what you see down toward the bottom, the record class generator. So it takes the AData output from a COBOL compile of the copybook and uses that to generate a Java class with the code required to support accessing those MVS type file structures. Now, we're not going to get into the detail of how you do that or how you use JOS, but we cover that certainly in our several of our classes at Themis. In terms of working with IMS, here we're really not talking about a standard batch environment, but as you know, IMS supports BMP type environment, batch message processing types of environments. And there is support for Java in IMS. Support in CICS, DB2, WebSphere, JES, the support for all those are things we'll talk a little bit more about. There's also a capability for direct language calls. But in order to invoke Java from COBOL, you need object-oriented COBOL, which hardly anybody is using. But you can also invoke COBOL programs from Java code. And again, this is a pretty low-level, technically intense approach, but it is supported. Not one that we're going to focus on. In the IMS environment, Java batch processing exploits the IMS capabilities for checkpoint restart and allows you to access IMS DB2 and VSAM types of files. So many of you with IMS background may be aware of MPPs and BMPs. The Java equivalents to those, JMPs and JBPs, support accessing through IMS databases, as well as other file structures. So this ability to take advantage of the checkpoint restart is a big benefit, and IMS has been supporting that capability for many decades now. From the JBP, the batch region, you can access the IMS message queues for output. Obviously not for input because they're batch-oriented and not message-oriented. But you get the capabilities of the transactional services and checkpoint restart processing. We'll give a little bit of detail of what that means, what transactions are, the all or none principle, and the fact that at a checkpoint, IMS commits changes. If you have a need to, you could roll back changes. And if the job fails for some reason, the checkpoints give you a capability to restart the job without having to rerun the whole thing. On the DB2 side, support for stored procedures is first mentioned. You can write stored procedures in Java. You can also call stored procedures from Java. And that allows you to take advantage of DB2's transaction processing capabilities, including two-phase commit. One of the benefits you see in the second sub-bullet below, the JVM is instantiated only once and then reused for subsequent calls to the stored procedure. And that can be a big benefit. Starting a JVM is going to cost, there's overhead. And being able to reuse the JVM and reuse the thread to DB2 can be a big benefit and can help out with scalability, being able to run a larger workload through that processing. A couple of notes about static versus dynamic SQL. In the mainframe world of COBOL DB2, we're pretty used to static SQL, where we compile and bind ahead of time, and DB2 then knows what its plan of action will be to execute our application. Static SQL can be a big benefit in terms of having efficient, particularly efficient message processing, online type processing. However, not supported in JDBC other than through calling store procedures. Dynamic SQL is something we rarely see in the mainframe environment of COBOL DB2, but does have some benefits. For instance, having better statistics at runtime could result in a better execution plan. However, the big downside is that compiling at runtime can have a massive cost and can really slow down performance, particularly in a high transaction volume environment. As most people know, stored procedures are pre-coded SQL plus programming logic contained and stored and bound into the database. They're very widely used, more and more so for various reasons. And using Java and JDBC, you can call the stored procedures. How you write the stored procedures, like I said, you could use Java or COBOL. Today, SQL PL is the preferred language and has its own set of benefits as well. Again, on the Java side, JDBC is a set of interfaces defined by Sun and now Oracle that are implemented by database drivers, such as the ones that IBM provides for accessing DB2. And the API, the Java API for accessing databases, gives you vendor independence. So if you switch to a different database management system, you can minimize the impact on coding changes. A quick set of steps on how to use JDBC is shown here. It allows you to access the data using SQL. Let's take a look at the steps at the bottom. You need a driver to be loaded. This is also part of what happens when you create a connection pool in WebSphere or any Java enterprise server. Using that driver, then you get a connection to a particular database, and then you create a statement, which might be select, update, insert, delete, or a call to a stored procedure. You execute that statement, process the results, which would be a result set for a select statement or just an integer value for update, insert, delete, tells you how many rows were affected, and then you close your connection. So Java lets you interact with DB2. Again, one of our major components here is WebSphere Extended Deployment Compute Grid, and that's our next topic. Being able to take some of today's COBOL batch workload and use Java to do that processing is one of the major goals of modernizing your mainframe development while keeping your batch applications. Now, there are various ways of running these batch applications, and in some approaches, we'll talk about the JZOS launcher, the JVM is created for every batch job, and maybe even for multiple job steps. And this increases CPU usage, resource consumption, and generally the cost of running that job. WebSphere, which has been around since the beginning, Java Enterprise Edition 1998, WebSphere, IBM was there and has, for the last 18 years, been improving and updating their product, provides many container services. There have always been the two containers in WebSphere, the servlet container and the EJB container, which we won't be talking about. But the new WebSphere Compute Grid provides a batch container. So in addition to the online processing, the interactive processing that WebSphere has been doing for the last 18 years, now there's a capability for batch processing as well. And that's the main focus of this part of our discussion. Lots of advantages: concurrent batch and OLTP workloads, online transaction processing workloads, running at the same time. Performance and scalability are also supported in a WebSphere environment. Centralizing server management, having a variety of tools, versioning support, health management of the server, and putting things into a WebSphere mode helps increase the enterprise's adaptability to business change. Things are changing, always changing, faster all the time, and this ability to adapt to those changes can be improved by having Java be supporting these changes as they come. So again, Java EE, or J2EE as it used to be called, has been around. It's been increasingly important over the past 15 years. There is a large and growing base of Java skills and Java EE skills. So the ability to offer a batch option within the Java WebSphere environment is big. It's important. And this can improve development costs, reduce development time. Again, many Java frameworks are out there, too numerous to mention, dozens of popular ones, hundreds more. Performance, a big focus for IBM and many others. And this makes the WebSphere environment very attractive for not only new applications, but even re-engineering and modernizing existing applications. So this is the traditional Java EE environment on WebSphere, showing web clients, EJB clients, message queue clients, web service clients, all interacting through HTTP, the protocol of the internet, interacting with the WebSphere traditional, you know, the transactional request response cycle. And WebSphere has been managing, among other things, the transaction processing in this environment, again, for many years. Some of the services that are supported in WebSphere and in other Java EE servers include security, transaction support, web service support, pooling of many things, including connections to the database, caching, messaging, support for message queues. These are all supported and required to be supported by the specification, the Java Enterprise specification. So this greatly simplifies application development in Java, accelerates development time, simplifies management, and provides a whole set of critical cross-cutting concerns: security, availability, performance, and stability among them. However, traditionally, batch was not supported in WebSphere. So integrating with traditional environments involved certainly JDBC for talking to the database, but connectors for talking to using Java connector architecture to talk to CICS or IMS-based transactions, using message queues to interact with COBOL batch applications. But now we have batch workloads supported in WebSphere using the extended deployment compute grid and able to run concurrently along with the transactional environment. So WebSphere now supports both. And this gives us the ability to consolidate servers, run batch and online on one server, and even more importantly, to share business logic that may have been developed over the last 10 or 15 years for the online types of applications and could very well be used and reused in the batch environment to help to speed the batch application development as well. So with Compute Grid, we have a number of additional features and capabilities, including a job scheduler, which you see at the bottom of the page, external scheduler, batch request into WebSphere. Above the external scheduler at the bottom, you see the traditional HTTP approaches that we talked about just a moment ago. So we have the ability now to deploy batch applications and interact with the JOS job entry subsystem using JCL, job dispatchers to be able to kick off jobs and manage and monitor, and actual job executors, which we'll look at in a little bit more detail. On the bottom right, you see how JDBC and JCA are listed as ways of interacting with other traditional environments like DB2 data and CICS transactions. Some of the key components in the WebSphere Compute Grid are XJCL, an XML-based job control language, which is very intuitive. A job scheduler that keeps track of the jobs, grid execution endpoints that are actual job executors, and the PJM for parallel jobs. If you look, we'll see on the next page a little more detail on how Parallel Job Manager. This supports a single JVM or a clustered environment. Some of you involved with WebSphere may know that clusters of WebSphere servers are a common capability, support both scalability and availability. There's a job management console and tables to keep track of job information that the schedule uses, and checkpoint information, which is also supported. Checkpoint restart are supported in the Compute Grid environment. Just a little more detail on the job scheduler, lifecycle management, job history, and the ability to dispatch those jobs to the batch container, the grid execution endpoint, where the job is actually executed and the logic runs. And then also at the bottom, the Parallel Job Manager has the function of breaking jobs, large jobs, into pieces, partitions, and executing them in parallel. So it's a more advanced feature and capability of Compute Grid. Now, just to back off for a moment, there is a JZOS launcher that predates Compute Grid and is still available and provides an integration point to the traditional ZOS environment. However, it lacks some key capabilities, including security, transaction and connection management facilities, including checkpoint restart facilities, and including other quality of service capabilities that are provided by the Compute Grid environment. Also, as you can see, each job step requiring Java reloads the JVM, the Java virtual machine. And that's overhead. That can slow things down. So comparing Compute Grid to JZOS, we see a difference on the bottom center. See the JZOS launcher above the Compute Grid arrow. The JZOS launcher using Java Standard Edition to run Java logic. The Compute Grid using WebSphere WebSphere to support Java logic. The similarity is on the right. The JZOS APIs are used either way to interact with the Z file system, hierarchical file system. Those are on Unix and vSAM. So really JZOS falls into two portions. On the right, the APIs for interacting with the file system. On the left center, the launcher, where Compute Grid has improved that situation over the JZOS launcher by itself. All right, so with Compute Grid, WebSphere controls the Java batch environment, and it does that by carrying out the job's lifecycle of potentially multiple job steps that need to be executed and multiple data streams for input and output to databases, file system, message queues, or other types of data. Among the bash container's responsibilities are the capability to open, close, and make checkpoint, restart, rollback calls to batch data streams that support that kind of thing. So there are a couple of built-in checkpointing algorithms based on time or record count, and also a built-in return code supplier that by default returns the highest step return code as the overall job return code. But these are both things that can be customized according to your needs. Now, our next little section is on JCICS, and it's a little bit detailed, but let me just begin by advertising next month's webinar, where we will have a 45-minute webinar just on JCICS. So I'm going to be short on time, so I'm going to go pretty quickly through this, but come back next month and you can get more detail on that. Java with CICS has been around for a while, and it's been improving. In version 4.2, the JVM server model is now being fully utilized, and this replaces a previous approach that was called pooled JVMs that wasn't as efficient. The Open Services Gateway Initiative is a set of technology that introduces a rich client development platform for CICS called CICS Explorer, and provides a not only a better development environment, but also some improved capabilities for working with Java, performance and scalability gains, among others. This OSGI initiative technology embraces the CICS bundle for packaging, deployment, and controlling the application lifecycle, meaning it's now possible to update a loaded CICS application without interfering with the CICS subsystem itself. All right, slide 46 talks about the pooled JVMs having been replaced by this better model, the JVM server model, which is a strategic direction, supports multi-threading, and gives you the ability to, again, repackage and redeploy an application with a minimal impact on the runtime environment. A little more detail on OSGI. The first bold bullet addresses excessive costs of class loading and class management. This is one of the downsides that was recognized in the CICS environment, and OSGI initiatives improve the performance and costs of those areas of class, Java class loading. Java classes are basically Java programs. And also allows your application to be developed into components and then dynamically refreshed or versioned. So this dynamic component model in the form of bundles for deployment allows for remote install, start, stop, update, and uninstall much more seamlessly. Brief mention of the CICS Explorer. It's Eclipse-based. It's been around a while. Its graphical interface runs on Windows as well as Linux, and allows you to connect to a CICS Plex or a single region, no charge, and lots of extensions for performance, interdependency, configuration, transaction plugins that can be added into the this CICS Explorer to provide a whole host of features for developing and testing CICS applications. On this kind of complicated page, what we're basically saying is that the Axis2 technology, which is the state-of-the-art Java-based web service technology, has now been implemented in CICS. And that provides a whole set of benefits, including, as it says on the very bottom, eligibility to be offloaded to the zip processor. So the integration of Axis2 is a recent and good thing, and this page talks a little bit about why. In terms of interfacing with other languages like COBOL, again, the ability to pass data between COBOL and Java is going to require some interpretation, especially on the Java side, whether you're using COM areas or channels and containers. There is support for this, so that Java and COBOL programs running in CICS can interact with each other. There is a CICS Java class library that provides equivalent functionality to the exec CICS programming interface. That's simply mentioned here, and gives you the ability to interact and integrate with other languages, like COBOL and PL1. And again, passing data between, whether it's two Java programs or two COBOL programs or Java and COBOL, using the COM area or channels and containers. This is all supported in JCICS, Java CICS, through various Java methods that are part of the API. All right, I know we're 2 minutes from the end, and I've still got about 25 slides to go, so I understand that you're on your lunch hour, many of you, and may need to drop off. The full recording of the webinar will be available on our website, and I'll just thank you in advance if you need to drop off. Thanks for coming, and stay tuned for other webinars in the future. Back to slide 54, we have MOM, Message-Oriented Middleware. It's been around for quite a while and has been kind of a staple of interacting between legacy and more modern systems, and the ability to send and receive messages through message queues and topics is supported in Java as well as many other languages. As you see on the bottom of the slide, this promotes loosely coupled architectures. So we have the ability for a program to interact with another program without having a clear understanding, need to know what kind of language that other program is written in. In Java, messaging is supported through JMS. And the details of JMS, obviously, well beyond our scope here, but we've given you a little bit of the terminology. JMS clients use JMS systems like IBM MQ. JMS providers are those messaging systems like IBM MQ. A JMS application uses message queues to send or receive messages. Someone who puts a message on the queue is a producer. Someone who reads it off the queue is a consumer. And in order to work with those queues, an administrator has to set them up using two types of objects, destinations and connection factories. All right, our last topic, I believe, is XML and web services. Seems like there might be one other, but yeah, we have about a dozen pages left. And we talk about, what XML is very briefly here. It's been around, certainly 20 years or so. And it is a specification that is recommended by the World Wide Web Consortium. And it's used in many environments, even just for data passing between you and your business partners. And it's fully supported in Java. Some of the uses, business to business, e-commerce, even storing data in files or databases. IMS and DB2 both support XML now as a data type. Used for exchanging data in a platform independent way. It's just text. And also used to configure applications, which is something that's been true for 10 or 15 years now. There's a little sample XML document in case you've never seen one. I won't get into a lot of detail on what's there, just to say that the first line is a header. The angle brackets enclose elements, and the data is the non-bold portion that you see, like July 25-29, 2016. And above that July date, you also see a title, which is an attribute that identifies some data for the class, the fact that it has a title. So it's intended to be both human readable and easily processed by applications, which is done a variety of ways, including parsing and generating XML documents. Now, one of the main reasons we bring it up here is because web services traditionally have been based on XML. They're defined as an interface that describes a collection of operations that are network accessible through standardized XML messaging. That's the standard SOAP-based web service, which has a number of benefits. It allows you to communicate over a network without being tied to a specific platform, operating system, programming language, and gives you a way to reuse legacy systems without having to rewrite them. It also promotes loose coupling, which allows you to swap out parts for other parts more easily, and is based on industry standard protocols which are listed above, like HTTP, TCP/IP, and SOAP. Web services can be used within an organization. SOA, service-oriented architecture, is something we're not going to talk in any detail about, but this allows you to set up your whole organization as services that can be called and written in many languages and support a variety of types of interaction. Web services can also be used between organizations, between you and your business partners. They may call web services that you provide. You may be calling web services that they provide, or both. This is increasingly a way that businesses interact. And there's also a role to be played on business to customer interaction, where applications that are deployed for use on the internet can be using web services to get at commonly needed information. So the web service can be written in Java as well as other languages and can be called by a Java application as well. What you see on the left is the consumer side, where a Java program could be the caller passing a request in XML format through some communication link like TCP/IP to some server like WebSphere, where another Java application could respond to it. WebSphere has built-in capabilities to support web services. On the framework side, Java Web Services, JWS, give you the ability to more easily use web services, whether that means writing web services and exposing them to the outside world, or calling web services. You can create a Java Web Service by just taking existing Java code and creating a description from it. See on the second to the last line, WSDL, WSDL, Web Service Descriptor Language, which can also be used to build Java classes, and there are built-in tools that help you get started with that. On the client side, the web service can be invoked by simply being given that WSDL and using the tools that are provided in RAD and elsewhere to generate a proxy class in Java that handles all the remote communication and allows you to interact with that web service in Java as though it were just another Java class that you're interacting with. One last thing is the newer kind of web services called RESTful. REST stands for Representational State Transfer, and gives an alternative way, often non-XML based way, to interact with a server resource. Has a much simpler interfaces and far less capability than the SOAP-based web services, but has been gaining popularity over the last 2 or 3 years as a simplified alternative to SOAP-based web services. REST is simpler. It is HTTP-based, which is typically true of SOAP, but not required. It's point-to-point, so you lose out on the capabilities that SOAP provides for intermediaries. It has far fewer standards, virtually no standards actually, where the SOAP web services, much more mature, have several dozen standards relating to things like security and transaction processing and many more. Both are mainstream. Today, it's really a choice that organizations are making when to use SOAP versus REST, or whether to use SOAP at all or stay with RESTful services. So, as you might guess, Themis has many courses that expand on all of these topics. We have Batch Java, we have JCICS, we have Compute Grid, we have web services. Any topic that is part of this webinar is available for you to take in full detail. And looks like just maybe 7 or 8 minutes past our 45, so I will stay on. If you want to use the chat window or question window in GoToWebinar to talk about anything or ask any questions, I'll be here. Thank you for coming, and hope to see you soon in a Themis class. Take care. Bye now.